All right, let's get started. Hi, I'm Lev. I'm the creator, founder of PgDog. Thank you so much for having me here. All right, so a couple elephants in the room. The pun is definitely intended. First, the logo. I obviously made this myself. I think it's good, but most people have told me it's not great, but I'm very proud of it. I used Inkscape, like the SVG editor, and I had a lot of fun doing it. But there you go. Um, Second elephant, I guess it's not really an elephant, but more like a background story is like how did the name PgDog or PgCat came about? I think some of you will probably guess, but I'm going to tell you anyway. PgCat was created in 2022, tail end of COVID, and we got a new cat. He's like a giant 18-pound orange tabby. Here he is. Uh, and at the time, I was between jobs, and I was like, "Oh, what can I do for fun?" Well, let's write a Postgres pooler in Rust. I don't think I'm a normal person, but whatever, that's okay. So naming projects is hard, and I was like, "Well, I love this cat. I love Postgres. Let's put the two things together." And here comes PgCat. Um, so that's mystery is solved. Now for PgDog, I think you might guess where the name comes from, but I'm going to tell you anyway. The year is 2025, I think. And I got a dog actually last year. And again, I was between jobs. And again, I was like, well, what do I do? What do I like to do for fun between jobs? Of course, write Postgres poolers. And again, I have a problem with the name. And I got this dog, and this is PgDog. This is the inspiration for PgDog. Simple as that. She is the cutest, awesomest 80-pound Bernedoodle. All right, so that is settled. Let's move on to connection pooling and actually why are we here and what PgDog is all about and basically what I'm doing. Um, so PgCat started as a connection pooler, and that was fun. And we used it a couple places, and that was great. But I think ultimately what I was trying to do at the time, but didn't quite finish, was to figure out how to build a real horizontal scaling, like universal horizontal scaling solution for Postgres. Um, we all love Postgres. It's our favorite database, obviously, because we were here. But unlike, NoSQL, like, Redis or Cassandra or, Scala or whatever, they all have, or even MySQL actually, they have like a universally accepted sharding solution, scaling solution, but Postgres does not. Postgres is still kind of like if you look around how people decide to scale it, how to shard it, how to like add read replicas and route traffic around, it's all pretty much like home baked, done internally, like one-offs. And that's about it. So every time a company runs into this problem, they kind of have to solve it all over again. And that's kind of unfortunate because people say like Postgres doesn't scale. I mean, obviously that's not true. You can you can stay on a single machine for decades, really. You can make that machine as big as you want. But at the end of the day, what people are really talking about is how can I add a second machine to my Postgres cluster without worrying about it. So this is what PgDog is all about. It's about sharding Postgres and scaling Postgres horizontally. Um, I've been talking to, I think I was thinking this is like an enterprise project. It needs to be, I need to look at companies that are like 5,000 people and more, like almost public companies to be used Postgres in production. But I've been talking to like 100 people companies, 150 people companies, and they're all like, we're maxed out on our, primary database. And we have like 3, 4 read replicas, and we need to shard and we don't know how. And that was kind of a crazy revelation because that basically means that sharding is actually more needed than I thought it is, and that's really great, but also kind of, scary because that solution doesn't quite exist yet, and everyone has to kind of solve it on their own. So PgDog, that's what it's going to do. Most of you guys probably run PgBouncer already, so the natural, since you're running a pooler already, might as well make it do more stuff, and that's what PgDog is going to do. But before we get into that, let's talk about PgCat because obviously some of you are probably cat people. So let's talk about that first and see what we learned. Well, actually, I should probably have like a side thing with my slides to tell me in which order I'm telling things, but that's okay. Uh, Let me tell you something about myself first, just to make sure, I'm not some random person talk to you about this. I've done this a couple times before. I've sharded Postgres at Instacart during the peak of COVID. That was a pretty crazy time. But we did, of course, like what everyone does in the Postgres world, is we did client-side sharding, where we modified our Ruby code, our Python code, our Go code, our probably even some Java code, and we added the sharding function in it. And we had to like figure out how to like split traffic between read replicas and write shards and all of that stuff. It was a crazy project, and it took months and months and months. We considered using Citus because, as you probably know, like Citus is somewhat used sharding solution for Postgres, scaling solution for Postgres. But at the time, at least, you could only support one coordinator, and you couldn't really like we had a really complicated, messy schema, like everyone does once they get to that scale, and we wouldn't be able to make Citus work with our existing schema and have like a zero downtime like migration to Citus. So it was not really an option. So the name of the talk is connection pooling. So I've been talking a lot about sharding, so you probably all like what's going on. So let's talk about connection pooling for a second. I mean, you probably all know what it is, but I'm just gonna tell it you anyway. Connection pooling is you have a scarce resource like a database like Postgres that can support, let's say 1,000 or 5,000 connections, which seems like a lot, but when you're in production at like a massive company or a massive organization of any kind, you're going to have thousands and thousands and thousands and thousands of Postgres clients connecting to the database at any given point and running queries. So Postgres can't do that. I don't think it's necessarily a limitation. I think that's probably a good thing, but we need basically a pooler. And a pooler is a proxy. It's a network application that sits between the DB and the clients, and it load balances traffic. And it does it in a very interesting way. You're probably wondering why there's a phone in the bottom right corner of the slide. Uh, well, some of you may not know, this is a phone from the early 90s. I think everyone here probably knows what that phone is. So, but I don't want to assume this is a Nokia phone. It's indestructible. I chose it on purpose because Postgres is indestructible. But so the idea is time time sharing multiplexing. So how it works is when you use your phone, even today, it connects to a cell tower. It picks one of the several available frequencies, and it sends data. It gets into a queue. It sends its data over the signal and kind of disconnects, right? So you think you have a continuous connection to a tower. It's actually not the case. You're taking turns with all the other phones in your area. So that's why when you go to like a concert or to whatever, your phone stops working. It's because there's way too many people getting into the queue, trying to send something, and you're just waiting and waiting and waiting. And that's the same thing. That's how PG Bouncer works. That's how any connection pooling works, is you get into a queue, you're one of the thousands and thousands of people, and you want to run a query. Now, typically, what PG Bouncer does is, or any other pooler, is it does it at the transaction level. It understands the Postgres protocol, and it knows when a transaction started and when the transaction is over, and it routes that transaction to a particular server connection. And that server connection is connected to that client for the duration of that transaction. And when the transaction is over, it disconnects. And that allows to, like most transactions, last, 1 or 2 or 3 milliseconds, maybe 5 milliseconds, maybe 10. That's what you kind of want in production. So you're able to share the same server connection between thousands of clients because most of the time, these clients are doing something else. Most of the time, they're either crunching numbers or talking to Stripe or, parsing CSVs, whatever it is people do these days. But when they talk to the database, it's usually very, very quick. So, conversely, if you have a very slow query, your pooling will be impacted severely. I don't have a slide to show you the stampede that will be caused by by slow queries, but that's basically the idea. So connection pooling it seems like a simple idea, but it's actually pretty complicated because like a lot of things can go wrong. Like for example, a client, like the typical problem with PG Bouncer or most connection poolers is the client will run a set state command and then change the server connection state and then go back to whatever it's doing. And another client comes in and the state is different. Notoriously, if you accidentally push like a PG dump through PG Bouncer, will literally it will literally like destroy all your connections because it'll set the search path to nothing. And then you're gonna get errors in your app that says no tables are found, and then you think somebody dropped your table and you're terrified. So there's some when you share a resource, you have to be like a good citizen, but it's not always that easy. But anyway, that's connection pooling in a nutshell. Um, let's see what I have next. So give me a second. Why did I build PgCat originally? The first innovation that came out of that project was really simple. It was the idea that we can use a pooler to not only serve one database, is that we can serve multiple databases. There's no sharding or any kind, just the idea that yes, we have one primary, we have multiple replicas, and we have a client that connects to them, and they just want to run a query, right? And to scale reads, select queries basically, we needed to send them to the replicas. At Instacart, we solved that again, like everyone does. At the client level, we had a library for Ruby. It's called Makara. I think it's still sometimes maintained. And what it does is literally there's a regex that says if the query starts with a select uppercase, I think lowercase not supported, it goes to replica connection. And if it's not, it goes to the primary. So you think that's dumb and it won't work because of blah, but it actually works. Literally 99.99% of the time, because most people don't write with select queries, but again, there's always exceptions. But that worked actually pretty okay until we realized that Ruby is really funky, and if you throw an exception at the wrong time, it messes up the internal state of your gems, and then everything breaks. And like load balancing of the client is just it's not a great idea. And then of course we had Python apps and Golang apps that didn't have that logic at all, so they were on their own, and their teams would have to figure things out themselves, and usually just they had increased downtime. We lost replicas all the time, just because life happens. So that was a major downtime event. So the first innovation, I was like, hey, let's put this in the pooler. It's a straightforward, like I don't need to do anything smart in here. Like again, if a query starts with a select, send it to a replica. If it starts with literally anything else, send it to the primary, and that works just fine. So that was great. But another thing that really was an unsolved problem is uptime. So when you have, multiple replicas, and again, one of them can fail, what you really don't want to happen is the client, like there's a simple round robin algorithm in your load balancer in your client, and it will just keep hitting the broken replica over and over and over again until it comes back up. So what would happen on Instacart is that we had a broken replica and it served like 33, or like we had like three replicas, five replicas, so like 20% of the traffic, 33% of the traffic, and 33% of our requests to our website would fail, right? For a long, long time until the clients figured out that the replica is down. Like we had like thousands and thousands of containers. They all had to make that individual decision that yes, that replica is down. We should stop serving, stop using it for queries. And then eventually the site would recover. So it would take like 20, 30 minutes. So the obvious solution here is again, like you have a central entry point for your traffic. Instead of having thousands of clients, you're going to have like maybe 20 poolers. So they can make that decision really quickly. And that was the second innovation that PgCat introduced, I think, to the ecosystem, is the banning logic. So this turns like again your Postgres pooler into a qualified load balancer. So we have this for HTTP. Like if you have multiple hosts behind your HTTP load balancer and one of them fails, your load balancer will remove that host automatically, and that's just a given, right? But in the Postgres world, we don't really well, we didn't have that. And that was really cool. That immediately we went from like, 99% of uptime to like 99% of uptime. That makes like a significant difference for us. And our SRE, SLA budgets. Well, those were always scary. So that was basically it. Like that's what everything PgCat did. I did it as an open source project between jobs again. I wrote some code and I sent it to a friend of mine on Instacart, and he's like, hey, do you want to try this out? And he's like, didn't you just quit the database team that would literally be in charge of doing this, doing this project? I'm like, yes. And now I have time to think about it. That's great. And he's like, all right, fine, I'll try it out. And then, after a few months of collaborating, we actually released it to prod, and they wrote a blog post about it. And it was great. Actually, they're still using it to this day, which I'm really happy about. But, just for the simple load balancing use case.
Hey,
Um,
Lev, I know that you probably don't want to spend a ton of time on this, but what was your prior relationship to PG Bouncer? Like, had you guys worked? I mean, I I really have only ever worked with PG Bouncer. Like, I know that PG Cat and PG Dog exist, but they're a little bit like in terms of deployment, maybe smaller across Postgres, and I'm sure it depends on the circle. But like what has your relationship been with that project? Like, had you contributed to PG Bouncer or like um yeah, I don't know if you're open to talking a little bit about that.
yeah, sure. No, we use PG Bouncer and Instacart exclusively. We had thousands of containers of PG Bouncer running everywhere. We we even forked it and added a couple, modifications to the C code to do some mirroring of traffic to do load balancing. We contributed a couple patches to the project. with bug fixes around like race conditions, around like settings, like max DB connections and all that stuff. We use PG Bouncer extensively at Instacart for years. Cool. All right, what do I have next? Let's see. Okay, well, without further ado, no, PgCat was fun, but it didn't do much beyond like simple query routing. We added a little bit of logic to handle like you can add a comment that says this should go to a particular shard, and then it will pick a particular pool to send the query to. And that was okay, but and they actually, I think at Instacart they did use it, and I think OneSignal uses that logic as well. But that wasn't very smart. You know, you still had to modify your client application, and there was no like real horizontal scaling story. Again, for Postgres, like horizontal scaling means scaling rights. Like everybody kind of knows how to scale reads. It's kind of a solved problem. It's kind of boring, but scaling rights is really where things get interesting, scary, and kind of, actually like where I think horizontal scaling comes from. So, you know, that's what I decided to work on today, to build a query router effectively, and logical replication manager, if you want like the technical term for everything it will do eventually, for Postgres. So the architecture looks basically like this. Again, PgDog is a pooler. It's a proxy. It understands Postgres. It understands SQL. It can read the SQL queries and route them to either like whatever private whatever shards you have, whatever replicas you have. So it's a strict addition to PgCat features. And what that architecture looks like today, at least, is something like this. So you have your pooler, you have your multiple primaries, you have multiple replicas, and it does basically it routes the read queries to the replicas, the write queries to the primaries. But instead of just looking at the first few bytes of the query to see if it's an insert or a select, it actually looks at the values as well and sees if there's like if this table is actually sharded. It can actually apply a sharding function to the parameters and send it to the right shard. Now, the sharding function I'm currently experimenting with is the partition by hash. So it comes from Postgres directly, which is kind of fun because it allows you to, split data inside Postgres and inside the pooler, and you get the same result. So that's where the project is at currently. It's probably 3 or 4 months old. I have like a pretty good working POC, still, working out the bugs and stuff. But I think it's looking pretty good. I think the idea at least is solid. So I'm pretty much iterating on that. So what you're looking at now is, from the PG Bouncer point of view, this is just like one of these databases typically would be handled by PG Bouncer, but PgDog would basically have, thousands of connection pools inside a single process, and they would know the difference between a replica and a primary and which shard and et cetera, and et cetera. So as I mentioned, the project's pretty new, so there's a few features I need to build still. It's going to probably take, realistically, to build something like this, it would take, years to be a viable sharding solution. So I better start sooner rather than later. What's next to the project right now is, the POC is there. I'm working on adding more cross-shard queries. So if you look at the docs for like VTest for MySQL, they typically recommend, don't use cross-shard queries. Make sure you go to a single shard at all times. I think that's usually a good recommendation for, 99% of your traffic, but the 1% is actually where companies make the most money because that's where the most important information comes from, like analytics and just like interesting stuff that may not fit a particular sharding pattern. So cross-shard queries are definitely going to be supported. Online analytics, not like, massive aggregates, but those are probably fine too eventually. I have like basic support for like count, sum, like the simple ones. I'm going to work on functions like average, which are a little bit more tricky, percentiles, which would be notoriously difficult, JSON functions, full text search. I think if you have like a sharded Postgres cluster that can do full text search, I think it'll be a great competitor to Elasticsearch. Because actually full text search in Postgres is actually pretty good, especially with all the extensions coming out that help with that. Um, yeah, I mean, I think threading is great. There's other features that PgDoc can support to help production operations smoother for people in general. Like, for example, the most common thing I hear people say is like, oh, somebody ran an expensive query. It took my entire database down. Like, what do I do? How can I stop this behavior? I don't have control over the users who write the queries. Well, the simplest thing we could do again at the pooler at the proxy is, you know, when a query comes in, we can get the query plan, see if it's expensive, and then let it through or not. You know, we can cache those things. So I think that might actually be feasible. You know, some stuff around like failure isolation that's a little bit vague, but I'm still kind of thinking about it. And some crazy ideas that I was also thinking about is, you know, fixing replica lag at the proxy with some synchronous commit stuff. But that's really, we'll see. That one's a little nuts. I mean, turning Postgres into like a consistent, you know, like distributed database would be amazing. But that sounds, it sounds interesting, but it might be a little bit off topic for now. And then of course, you know, moving data between shards, logical replication, all that stuff is still on the roadmap. Uh, yeah, so I have one slide left. Let's see, what do I have here? Oh yeah, final slide. What's going on? PgCat, I'm not working on it anymore. It's in maintenance mode as far as I know. So everything that's going to happen that's exciting about this project is probably going to be in PgDog. It's almost drop-in replacement for PgCat, you know, minus the config has changed quite a bit. So I probably need to write some kind of config converter. If any of you guys are even using PgCat, like let me know. I'm happy to write a config converter to make it as smooth as possible. Another interesting thing that's different this time is PgDog is actually a company. I founded that last month. I got some funding as well, which I should announce pretty soon. So why is that different is because, you know, PgCat was an open source project that I did for funsies on the side, but this is going to be my full-time job going forward. So, you know, this is going to be a long project. It's going to take several years. So, you know, if I'm successful, fingers crossed, we'll actually build sharding for Postgres and make it into a sustainable business. Of course, and the last most important thing, yes, I will get a new logo. I have a professional working on the logo, and it's going to be fixed hopefully this week. If not, I have a backup logo, but we're not going to talk about that. Thanks so much.